In this lesson, we're going to be talking about piecewise functions. A piecewise function is made up of separate parts. We call those the subfunctions. Each portion is defined by a different equation over a different interval, a subdomain. The general idea of a piecewise function is I'm taking a piece of a graph and I'm only graphing it for a certain number of x values. The x values are indicated by using the inequality signs. So for this example, our function has two subfunctions. We're going to graph the linear function 1/2 x minus 1 to the left of -2 because they tell me that I'm only graphing that when x is less than -2. So you see that, and we have the equation and then the semicolon and then the domain. To the right of -2, we're graphing the line 2x minus 3 because they've restricted that subdomain to be where x is greater than or equal to -2. We also use open and closed circles to help us define when the domain is equal to a number or not equal to a number. It's very similar, exactly the same as when you would graph things on a number line. We use an open circle if it's not equal to, and we use a closed circle if it is equal to. So we see in the first subfunction, 1/2 x minus 1, we're using an open circle at the top of that line because we're not actually including that point. We're just really using it kind of as a dividing line between the two. And then on the second subfunction, 2x minus 3, we use a closed circle because we are including that point in that part of the domain. When we start thinking about graphing and determining where parts of the graph are starting and stopping, we can use a dotted line, and I tend to think of that dotted line as a fence between territories. So I can only graph in the part of the graph that is fenced or belonged to that subfunction. And then we have to decide who owns the fence, meaning that typically when we have a piecewise function, it's only defined for one of those values in the subfunction, so we have to decide which of those gets an open and a closed circle. So we're going to work this example. We're going to graph this. We're going to use our fence, and then we're going to use our domains to help us with graphing and kind of understanding piecewise functions. The first thing that I'm going to do is identify the subdomains, which again are at the end of each row. So I'm graphing one function when x is less than -3, another function between -3 and 2, and then a third function when x is greater than 2. So once I have identified the subdomain, I'm going to take and draw the lines. So what I'm looking for are these numbers that are shared in these domains. And that tells me where the fences are going to be. So there's a fence at -3. So I'm going to draw a dotted line. Now, as you're looking at graphs in books and on examples, they don't draw these dotted lines, but they're just helpful for us as we're first starting to learn about these functions. I also have a fence at +2. So I can draw that in. That's just a visual reminder for me that that's the territory in between the fences, and I have to figure out which of those equations I'm using where. So I'm going to label in these boxes at the top. When x is less than -3, I'm graphing the function the opposite of x minus 3. So it's a linear function there. In the middle section of the graph, we're going to be graphing the function x squared plus 1. And then the last part of the graph, when x is greater than 2, I'm graphing the constant function of 3. And then we just have to start to put together what we know about transformations and graphs and parent functions to help us kind of quickly sketch this graph. For the graph to the far right, 3, that's a constant function. It's a straight line. The y values are always equal to 3. So on the y-axis, I'm going to come up here to 3. But note that I can't start graphing that line until I get to the fence. So I have to jump over to the fence to show that that's where I'm graphing y is equal to 3. In the middle part of the graph, it's a non-stretched quadratic. It's been shifted up 1 unit, so I know that the vertex has to be at 0, 1. And I know that I can't go beyond those 2 points to the left. So one thing that we can do is actually take and plug this number in on the fence. So when x is 2, so 2 squared is 4, 4 plus 1 is 5, so the point 25 would be right here. And that one is the owner of the fence because it's equal to on that value in the subdomain, which means that the other one is an open circle because it is greater than 2 but not equal to. So the fence belongs to the one in the middle, actually for both of these equations. So we can also go ahead and plug in -3. -3 squared is 9, 9 plus 1 is 10, so along that fence we're going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're actually all the way up here at the top of that graph. And I'm just going to sketch that picture. And note that there's no arrows because the domain is broken into this territory, so I can only graph that parabola between -3 and +2. For the last one, we have a linear function. It has a y-intercept of -3. So I can go down here and go ahead and mark that -3. And it has a slope of -1. So I would be going and working backwards, going up 1 over 1. We could also plug in the number on the fence. We could plug in that -3. So all we're saying is I'm using some function notation. There's not really a right or a wrong way to graph these. A lot of it is really just in how you remember some of these rules and things from your previous math classes. So the opposite of -3 is 3, and then 3 minus 3 would be 0. So on this graph we have the point 0, -3. I'm sorry, -3, 0. Because we were looking at the line. It's not included, so we're going to use an open circle for that point. And again, if we had started down here and counted, backwards with the slope by going up 1 over 1, we would have eventually landed there as well. I just decided to go ahead and use that fence. So again, more than one way to do these and graph these. We're going to keep working back with the slope, up 1 to the left 1 to get some other points, because we're going to be graphing to the left of that. So if we take out some of these extra things that I put in here, we can take out the fence. You can leave it on your notes, but I just want you to see what this would look like without all of kind of the support and extra things that I put in for myself to make sure that I'm graphing it correctly. This is what that graph would look like just by itself. And here's another picture just so you can kind of see again. That's just that nice kind of clean picture of what that looks like without the support work. One of the important things is just don't forget to check who owns the fence, meaning who gets to use the open circle and who gets to use the closed circle on each of those kind of breaks in our subdomain. So let's graph another example. So again, we have 3 parts of our subdomain.